On this edition of the Open Alliance Show, we welcome on a twofer. It's 111 and 112, WildStang and +1, the legendary program coming in from Illinois. We'll be joined by some students to talk about their strategy, how they approached it both together and separately, and how they're kind of diverging apart. It's really interesting to hear how each team is approaching this year's game. We'll hop into the CAD of both these teams, talk about what their initial prototypes are going to be looking like, and where their current progress is going to be. You got to stick around for 111 and 112 here on the Open Alliance Show. This video on fun is brought to you by viewers like you and also in partnership with the following. AndyMark is your one-stop shop for all your robotics competition needs. Celebrating 20 years of quality robotics parts and superior service, AndyMark employees have over 200 years of first-team experience. From mechanical and electrical products to tools and hardware, head on over to andymark.com for high-quality and affordable solutions. Support Fun's content creators when you sign up for a membership on YouTube Join. You'll get access to special perks like emotes, loyalty badges, and Fun members will even get early access to our scheduled videos and more. 100% of this revenue will go back to our correspondents to help recognize their efforts. Click the Join button in any YouTube video to pledge your support. And welcome into the Open Alliance Show. It's joining us for the first time in the Open Alliance. We have 111 WildStang and 112 +1 coming out of Illinois, a team that I have a really long history with, so it's really cool to see both these teams on talking about a whole bunch of stuff, strategy, analysis, and techniques. And we're going to be diving into both 111 and 112's builds so far as they've gone through. So we got three fantastic students on right now. Hey guys, if you don't mind, can you just introduce yourselves? Let us know which team you're on and what you do on the teams.
I'm Colin. I'm on team 112 and I do strategy.
I'm Adrian. I'm on team 112 and I'm in electrical.
And I'm Elliot. I'm on team 111 and I do CAD, electrical, and mechanical.
So we were talking a little bit before show, and I think this is really cool that, your two teams together approach a lot of strategy together as one when you look at how you're going to approach your robots for things. So let's dive into your strategy analysis and some of the techniques you go about doing that, and walk us through what you go through and kind of what the last 2 weeks have been like.
Yeah. So despite a lot of strategy being to work together between two teams, obviously, each team is going to develop their own strategy for the game. So when 111 went into the season, we have a flow chart that we always show at kickoff, where 111's goal is always to win events. How do they do that? They pick the best alliance. How do they do that? They get first place in quals. And how do they do that? They win matches and they gain RPs. So while we were brainstorming about how to best get the RPs, we decided that neither of these are realistically attained solo, so we needed to find a way to maximize the likelihood of the ranking points. Obviously, with the melody ranking point, the goal is just to score as many notes as fast as you can. But the ensemble was a little bit more interesting. So we created a chart to see exactly what endgames would get us the ensemble ranking point. And we decided that two of the most common ones that we would see was a triple climb with 1 harmony bonus and a double climb with 1 trap bonus. And so 111 decided that the best way to maximize the ensemble probability is to be capable of scoring in the trap. Now, on the 112 side of things, we decided that our goal for the season is to be a first pick at the regionals that we're attending. And so in order to do that, we decided that we would be building a robot for elims matches, not for quals matches, which would mean that ranking points are a lower priority. So when deciding what design factors would go into our robot, we decided for elims, we needed to be capable of both speaker and amp shots. And those cycles need to be fast and consistent, or as some of our mentors put it, we need to have the zoomies. We also will need a fast climb to get endgame points fast, and we'll need to fit under the stage for faster cycles and more evasion of defense. To try to map out what a limbs matches might look like, we developed these cycle time charts, which you can see on the screen now. We're developing this project to try to map out strategies for different alliances that we might see within elims matches. We have variables of cycle times for all 3 robots in an alliance. So that means the speaker cycle and the amp cycle for the captain, the first pick, and the second pick can all be changed. And the goal is to see what the maximum number of points in teleop that we can get with these different alliances is. And we think this will really help us decide what we'll be looking for in scouting, so that we can see how we can best achieve this goal.
Couple things I want to ask you, especially looking at the 112 philosophy of building a robot that is really good for playoffs, sort of thing. When you approach that, are you kind of like you mentioned before? 111 wants to seed high, win the event, things like that as the alliance captain. From a 112 perspective, do you look at like if are you trying to be picked by 111, so to speak? Then, if you kind of follow that flow as you go through, if 111 is going to be the number one seed, is the goal essentially to have 112 picked by 111 and kind of, or at least imagine like that type of situation?
Well, obviously, being picked by a Hall of Fame team is never a bad thing. But yeah, if 111's goal is to seed number one and 112's goal is to be a first pick of a high alliance, then I guess that strategy would align. But we're not like building a robot to facilitate 111 during the wins.
Yeah, and that's kind of my follow through on that is like, where does that differ then in regards to, you talked about, the strategy for 112 and how you feel about that. Is that then completely independent on that aspect of like, hey, we obviously want to be compatible, but we're not building a robot to be compatible with 111. So how does that strategy on 112 veer off at some point to where you're just going your own way and not worrying about what 111 does?
Yeah, so our robots are built completely separately. We're each going to have our own strategies. There's a very good chance that we're not going to be on the same alliance. And so 112 and 111 both have to build that can do well regardless of the alliance that we're in.
No, that totally makes sense, and from that approach, it's really interesting. One thing I'll ask you as we start to get into builds a little bit in just a moment is, do your two teams, do you build at the same time? Do you collaborate? Like right now that we're past the strategy phase, are you still collaborating at this moment, or have you pretty much branched off your own different ways?
Well, as 111 and 112 both build prototypes, both of the teams can learn off of those. But really, at this point, each team is CADing separately. We're building separately. We're really focusing on our own robots at this point.
Well, let's talk about that a bit and dive into the builds of both of your teams as well. Who do you want to start with between the two?
112 can go first.
Perfect. So yeah, let's dive into what 112 has been working on, and let's showcase some other cool stuff. I know I've been reading your OA blog, so much detail on that. So I hope teams, you are going into their OA blog to read more about it. But let's bring up some CAD and talk about your current progress.
All right. So for 112, our design criteria were to have mechanical simplicity, how simple it is to build, a low center point of gravity, because we expect this game to have a lot of high-speed collisions. We want to be small. And we have an Undertaker intake. The Undertaker intake, we took inspiration from Team 95, the Grasshoppers. It's basically an addition to the drive base that our intake will be protected by the bumper and essentially has an empty rectangle where we can put our intake. And we decided to use the Undertaker design over a traditional under the bumper and over the bumper design because the Undertaker allows us to have a bigger area of pickup for the notes, leading to our driver having an easier time to pick up notes, which would lead to faster cycle times. And talking back to our strategy, we want to be a high-scoring robot, and that's why we need faster cycle times. And the Undertaker will protect our intake, so we won't run a high risk of damaging it in competitions. Some reasons why we didn't use a traditional under the bumper design was under the bumper designs have a smaller area of pickup because you need room for the sort modules. And we calculated it. I think we have like 14 or 13 inches of clearance for the note, which isn't a lot when the note is 12 inches wide. And why we didn't choose an over the bumper intake was because over the bumper intake, like last year, we didn't really have, we don't have much protection. And like we predict that there's high speed collisions in this game. We don't want a chance of breaking mid competition. Our intake consists of a polybelt, multiple polybelts spinning in parallel with complement wheels on the inside. which have a quarter of an inch clearance from the ground, which would facilitate picking up notes from the ground. Our shooter, we decided to go for a low pivot shooter because we wanted a low center point of gravity, which would lead to, since we predicted it's a high contact game this year, we don't want a high center point of gravity because we don't want it to be tipped over. Our shooter consists of vertical rollers. We decided to go with vertical rollers over horizontal rollers because we like the way how vertical rollers act upon the note and how it shoots and how easy it is to aim. And we also have a feed, which feeds the notes from the intake to the shooter. And that's just the complement wheels, as the same ones as the intake.
And then from climber wise, what is your team currently looking at doing? Because you mentioned in your objectives that you wanted to go that route of having a low bot for that. So where is that climber actually looking to be attached on this robot?
We're still not sure, but we're thinking about the idea of putting it with the shooter, if not having a telescoping arm, but we don't really want to go with the telescoping arm route since it would add a lot of unnecessary mechanical complexity. And that's one of our design criteria to not have mechanical complexity. So we're just thinking on adding the climber to our shooter.
One thing I want to ask you, especially for your intake wise, we see the CAD for it. What type of prototyping has your team done to verify this is going to be the right type of intake for 112 to move forward with?
We still haven't really started prototyping our intake. We're starting that very soon, but we just like this concept and we think it would probably do pretty well in competition.
Yeah, and obviously having the super wide intake is really valuable. I'm sorry, go ahead.
We've also seen other teams have these intakes before, and other Open Alliance teams have shown off these intakes, so we know that it's going to work.
Yeah.
So what are some next steps for 112? We have a lot of this CAD'd out. You mentioned, still got to figure out the climber, right? But past that, looking into like the next week or so, what are going to be the really hard-hitting things for 112 to tackle?
Just getting our drive base set and getting our shooter, because this shooter design, we're probably going to change it to some of we don't really like some of the geometry, so that's going to be very hard to fix. So we're going to set our priority to working on our CAD for a shooter for the next week. But other than that, we're probably going to start building the drive base later today and our intake possibly today as well.
Well, of course, looking forward to seeing the progress for 112 as well. Great CAD, and love the Undertaker thought process and design for that. So really looking forward to seeing those updates on your OA blog as well. Let's jump over to 111 and talk about their current progress right now. Once again, reading through your blog, I saw just a few days ago you were testing dry bases. I did see a couple prototypes as well too out there. So tell us where you're at right now from current design phase and starting to move forward with that.
Yeah, so I want to go through all of our previous ideas for robot archetypes. Do we have time to do that?
Yeah, let's do it.
Okay. So so we have had it out about four different robot possibilities that we were thinking of. The first one is we have this elevator that's in the middle, and it comes up, grabs the chain, comes down, and it also has a shooter on a pivot. That's one of ours. I'm just gonna go through the other four. So our next one is we have the shooter on a pivot on an elevator, and the shooter goes directly. Our intake goes to the shooter, and then the shooter can pivot up and then pivot out to go into the amp. But the problem with this is you'd need to be on an elevator to go to the trap. So this has a lot of degrees of freedom. So it's not a very good design for us because we want to make a simple robot that we can build kind of quickly. And the same one for this one, you have compounding degrees of freedom because you have the shooter on a pivot on an elevator, and that just adds unnecessary complexity where we have some other ideas that would work without having to keep our shooter on an elevator. All right, so that leads us to the next one. And this one we fully Crayola CAD'd it out, where we have our shooter we have an under the bumper that goes straight to our shooter, and our shooter can go up onto this 90-degree thing that is the Rembrandt's posted about this, and I think also Spectrum, where it would go up and it would deposit to the amp, right? And for this, you don't necessarily need to have the shooter on the pivot because you could do a handoff and have the elevator go up. However, we don't really like this way because we thought of a different route that's better. And this one is the one that we are planning to build now. We have a under the bumper intake that's fixed that goes into our feed, and then the feed stores our note, and then we can decide to do one to two things about it. So either we bring the lift up really fast and then it deposits the note into the amp, or we have it feed into our shooter, which is on a pivot. And then when we feed it into the shooter, then we can have it shoot out. And this we really like because first off, we can make this really, really light. And then second off, we have the degrees of freedom not compounding. They're both separate. So we only have an elevator and we have a shooter on a pivot. We don't have to have these in the same thing.
I want to ask you on the elevator real quick. When I think about the process of how you go about that, right? Because would you visualize yourself lifting the elevator as you're in process of doing a cycle, or do you have to get there, then lift, and then score, just kind of based on your CG that it's looking at right now?
So we can lift it basically as soon as we know we want to go for amp, because this lift is meant to be extremely light. We're thinking 1/16 wall aluminum here, and then this carriage could be literally 3D printed out of onyx,
Sure,
or machined out of polycarbonate. So it'd be a really, really light elevator, and then that also allows us to move it really fast too. So, yeah.
Before, when you mentioned your objectives for 111, you talked about like you noticed that you're going to need to get 2 robots on, right? Is your team right now planning on doing anything past like I'm guessing that's your climber that's right there. Are you looking to do anything past to do like a buddy assist or anything like that? Where's kind of the thought process there?
So our robot's capable of doing trap. I want to go into more about that later.
Sure.
So since it's able to do trap, we really don't need to do an ensemble climb. We can just climb by ourselves, and then our partner can climb on another chain. We expect by week 2, most elims, week 3, our first event. We expect that most of our Quals alliances will have another climber. So one of the 2 robots connected with us will have another climber. Like this year, and every bot can climb the chain. The Rev bot can climb the chain. The West Coast Protest bot can climb the chain. Like every single bot we've seen should be able to climb the chain. So we expect a lot of functional chain climbers. So we don't need an ensemble chain climb. And it would add a lot of unnecessary complexity to the robot as well.
Yeah, no, that totally makes sense in there. One thing in regards to the note on it, can you kind of show us what that process would be like in regards to scoring the note onto the trap, essentially? Like, how does that flow actually work in regards to where the note is going on your robot?
So the note would first feed into this feed, and then we bring these arms up, and then we'd align with the stage. We'd bring this lift all the way up, and then we would pull down with our arm, and that would get us to the trap. I want to show some geometry now that we have that we CAD'd out a while ago, that we were pretty much always thinking about for this arm. So basically what we were thinking about for the climb to be able to go up really high is that we need to basically bring the chain underneath our bumpers. Or as we figured out later, we can bring the chain really far out because this chain actually swings on an arc, right? So if we push it far out, the chain actually goes a lot higher than where it would be if it stayed in the same place. So this climb works by bringing an arm down, and we bring our robot up, and then by the time the arms are out here, we're at the height required to score amp. if we had a wow, this geometry's not being nice to me right now. Let me just undo that. I think that should allow me. Okay, yeah. So if we had a wedge on the bumpers, we would be able to get all the way up. I have a video, I think I posted in Spectrum a while ago, but yeah, we're able to get up very high with this. And this arm climb, we think, is going to be very, very helpful for getting up high and being able to do drop very well.
All right, well, definitely looking forward to seeing the continued progress, especially as we start to see more prototypes come out and you start your build process for that. Make sure you do check the 111 and 112 OA build logs on Chief Delphi. Hey, guys, before we let you go, anything else that you really wanted to cover or talk about, or any major next steps you want to mention at all?
Not really.
Don't think so.
Awesome. Well, good luck the rest of the way. Thanks for coming on, and we can't wait to see your continued progress. Thanks, guys.
Thank you.
Thank you.
This video on fun is brought to you by viewers like you and also in partnership with the following. AndyMark is your one-stop shop for all your robotics competition needs. Celebrating 20 years of quality robotics parts and superior service, AndyMark employees have over 200 years of first-team experience. From mechanical and electrical products to tools and hardware, head on over to andymark.com for high-quality and affordable solutions. Don't forget to like, subscribe, and ring the bell to stay up to date on our new videos. Keep the conversation going and provide your input to our content. Watch our live shows at twitch.tv/firstupdatesnow. Join our Discord at discord.gg/firstupdatesnow and check out Fun FTC on Facebook, Instagram, and Twitter, and First Updates Now on Facebook, Instagram, TikTok, and Twitter.